The first section of Chapter 5 is simplifying expressions involving powers. Now to do this, we're going to use properties of exponents. And properties are things that just hold true. We know them to be true. For example, a property of water is that it's a liquid, and you learned in geometry that a property of a square is that it has 4 congruent sides and 4 right angles. Properties are just things that are true. It's a part of something. So first we need to remember that if we have a term that's to a power, like x to the 4th, that just means that you have that base, so our base here is the x, times itself 4 times. So we'd have x times x times x times x. This is important to remember when we're going over these properties. So in all these, a and b are real numbers, and m and n are integers. And integers are just positive or negative whole numbers. So your exponents are going to be m, and they're always positive or negative whole numbers, or integers. The first property we're going to talk about is the product of powers property. Now the name gives a hint to what's going on here. A product, meaning multiplication, of powers. So we're going to have 2 powers times each other, and we can use this property. Now we can only use this if it has the same base. Notice that our 2 numbers have the same base a. So for example, if we had 5 to the 3rd power times 5 to the negative 1 power, we have the same base here. So what we can do using this product of powers property is take your base, which is 5, and then you're going to add the exponents. So you're going to do 3 plus a negative 1, which is 5 squared. This is your simplified answer, and this is also called exponential form. If you are asked to evaluate, then you would actually take 5 squared, which is 25. So this is if you were to evaluate. So it's important to understand what you're asked to do. The second property is the power of a power. So we're going to have a power, and we're going to take that whole thing to another power. So for example, if you had 3 to the 3rd, and you took this whole thing to another power. So let's say this whole thing is to the power of 2. What you do then is you multiply your powers. So you still have your base down here, and you multiply your 2 powers. So I'm going to have 3 times 2. So my simplified answer is 3 to the 6th, and if I were to evaluate, 3 to the 6th is 729. Next property is power of a product property. That means you're going to have some product, multiplication going on, and the whole thing is to a power. So here a times b, let's use a specific example. So let's say we had 2 times 3, all to the power of 4. Now you might think right away, well, this is just order of operations. I can take 2 times 3, which is 6, to the 4th. That's true, you can. But pretty soon here we're going to be throwing letters into these expressions, and you're going to need to know these properties. So the property says what you can do is basically distribute your power. So you can rewrite it as 2 to the 4th times 3 to the 4th. And then if you had to evaluate that, you would do 2 to the 4th times 3 to the 4th, and you would get 1,296. The next property is the negative exponent property. This property gives you a way to make an exponent positive because a truly simplified answer has no negative exponents. So if you have negative exponents, your answer isn't simplified yet. So let's say we had 7 to the negative 2 power. If we have a negative exponent, what we can do is just flip it and put it over 1. And that makes your exponent positive. So this would be fully simplified. So if you have a negative exponent, just flip it, put it under a 1, and make your exponent positive. The zero exponent property says if you have anything to a zero power, it equals 1. So if you have negative 89 to the zero power, just equals 1. It's a pretty easy property. And we have 2 more properties left. The quotient of powers property would mean that we have a quotient of 2 powers, and quotient meaning divide. So let's say we have 6 to the negative 3 over 6 to the negative 6. Now, in this property, the bases have to be the same. You see we have A and A. So this only works if you have bases that are the same. What this says is when we're dividing, you're going to subtract your exponents. Now, if you remember in the property above, when we multiplied, we added exponents. When we divide, we subtract. So you just take your base and subtract your exponents, and your top number is going to go first. So we have negative 3 minus, be careful with your signs, a negative 6. And a minus, those turn into plus. So you have negative 3 plus 6. So your answer is 6 to the third. That's simplified. If you had to evaluate it, you would actually do 6 to the third, which is 216. Now our last property is a power of quotient property. So this is almost kind of like the opposite. Now you have a quotient inside of a power. So let's say we have a quotient 4/7, and that whole thing is squared. This property says that you can distribute this squared to the top and the bottom. So I could have 4 squared over 7 squared. And then if I actually do that, 4 squared is 16, over 7 squared is 49. That doesn't simplify any further, so that would be your answer. So those are the properties you're going to use to simplify and evaluate expressions. So let's throw some letters into the equation to use these properties. This first one we have b to the negative 4th times b to the 6th times b to the 7th. It's all multiplied together, b times b times b. So if you look back up to your properties, we have the product, meaning multiplication of powers property. When everything is multiplied together, we add our exponents. So all I'm going to do is take b and add all my exponents. Negative 4 plus 6 plus 7. And that gives me negative 4 plus 6 is 2 plus 7 is 9. So this simplified would be b to the 9th power. Pretty simple. Now these can get pretty complicated pretty fast, so next class you're going to be doing a lot of examples of these because there's so many different ways they can be written. So if we look at this example, we have division and everything in the top is multiplied together, and same with the denominator, we just have multiplication. So this makes dividing really simple because we just divide our like terms. So if we start with our coefficients, our 16 and our 2, divide those. This is a fraction bar, meaning you divide the top and the bottom. So 16 divided by 2 would just give you 8. And if it helps, maybe circle what you're dividing so you know what you've divided. I did 16 divided by 2, which is 8. That's done. I'm going to move on to my m to the 4th. There is not an m in the bottom, so I can't divide this by anything. So nothing changes with my m. I'm just going to keep it there, m to the 4th. And if it helps, cross it off when you're done. Now I move on to my n's. Now if you remember the properties above, there are several different ways you can do this. Probably the easiest is they have the same base in n, so just take your base and subtract your exponents because this is division. So I have n, negative 5 minus a negative 5. And negative 5 minus negative 5 is 0. So that means I have 8 m to the 4th, n to the 0, and anything to the 0 power is just 1. So my answer is really 8m to the 4th. And that is my answer. So I want you to go ahead and try to simplify these two examples. Simplify meaning don't evaluate, so just simplify this in exponential terms. So you're going to use the product of powers property. And here there's a couple different steps. You can do it a couple different ways. See what you come up with. And we'll talk about different ways to get to the answer next class.